Hello everyone, this is Anshuman Tiwari. I'll be presenting here a project on bank customer will leave the bank or not based on the given data set. We'll be using a deep learning neural network model. Let's begin. We have imported the libraries and the data set, and we saw with the head function we saw the number of columns also we saw and adjusted it according to which were not required and required. And then we saw we have two categorical independent variables among our variables which are gender and countries. You can see France, Germany, and Spain, and here in female and male. We'll be transforming it as to transform as both non-numerical column into numerical array. For gender, we use this label encoder, and for encode categorical feature as one or numerical array. Applies transforms to column or data on or pandas data frames. Now we will be splitting our data set into training data and test data sets. Then we'll be featuring scale. We'll be using standard scaler, and we need to apply this scaling to our ANN because of calculation and parallel calculation easiness. Then after that, we got our well-ready and pre-processed data in our XTrain. Now is the interesting part begins. We imported the Keras library and sequential module to initialize our neural network, and dense module also required to build layers of our artificial neural network. From Keras model, we imported SQL, and layers we imported dense, and dropout is for improvising our artificial neural network, and it's used to avoid overfitting problems. So we initialized our artificial neural network. That's it. With sequential, it is done. Now we are ready to add different layers in the artificial neural network from input layer to our hidden layers. In input layers, we have used this our model. We add the dense function, and we use the outputs, dims, and dimensions, and we use activation function, ReLU, rectified linear unit, and we use initializer, kernel initializer, uniform, and input dimension. This is 11 number of our independent variables, and there we go for our dropout method, which will avoid overfitting problems and refine our prediction results and accuracies and of the model. So, and after that we added hidden layer, and in hidden layer also same we added this dropout, this one more we use for our hidden layer as well. And output layer we are using here as output ms1 because we are going to predict it between yes or no, right? We are going to predict it like that, whether the customer is going to leave or not. So that is the activation function. Here we used was sigmoid. Sigmoid is used for this probability and predictions only. So we use sigmoid. Their initializer same again, and after we are done adding layer to our ANN, we are going to compile whole artificial neural network and applying gradient descent on whole ANN. That is what compile means. Here we use compile and optimizer. We use which is also Adam algorithm we are going to use to find optimal sets of weights to our neural network. Here its gradient descent algorithm is based on loss function to optimize weights, loss function, binary, cross entropy, and metrics as accuracy. So now we choose number of epochs. We are going to now fit our ANN into the training set, which after that we are fitting, we use batch size. Batch size is for number of observation, after which we updates our weights, and second is number of epochs. Epochs will be how our ANN is trained, and see how each time is run on each epochs. We'll be running it that time, and then after that it is run. It took a while, like it will take some while, and then after our accuracy has been come and model has been trained. Now we'll be seeing the prediction of the test results. We'll see our model we took, and we predicted our X test results. We saw it 63 out of 63, and then we see this our Y prediction, and this which was false, false, and true and false. It is predicted on the basis of true and false. Now from this we'll be testing our accuracies. Accuracies are like we have tested importing our confusion metrics, and accuracy scores like we have done in a machine learning. And here I have taken a problem. Here a customer data has been taken and try to fit that customer data into our model which we have made classifier. Here I have taken that data into an array and transformed it into the standard scaler and predicted over our classifier model. So that was our prediction results, which tells 1, that means false. Congratulations, our customer is not going to leave according to the data he has been provided. We have been provided by the bank. Now we see evaluating our artificial neural network performance. Accuracy changes with the number of data sets you put into your model, and therefore we cannot judge our model's accuracy on just one run. This problem is solved by k-fold validation. Therefore, in k-fold you use 10 folds of combinations of 9-fold to train the data model and 1 to test it. Therefore, 10 combination of training and test sets will analyze our model. So let's implement k-fold cross-validation here on our artificial neural network. Here we have run the program again, and after running the program we see the accuracy got 85.9. It changed. Now K-fold belong to scikit-learn and Keras means artificial neural network. So we'll be using Keras wrappers classifier. Here we have used Keras classifier and wrapped it with scikit-learn Keras. Wrapped k-fold validation of scikit-learn into Keras, right? So after that we have used this cross-validation function. We imported it and same we did sequential and dense for our layers and initialization. So now we have tools. Now let's build a function which, since Keras classifier is used via this function. We build this classifier and same like we have built our artificial neural network, we all did here also. We compiled it with the same optimizer algorithm and everything, and we return here our model. Now we have taken this Keras classifier and give it this is output variable, output uh, this is global. We have given it global classifier name, so it will be a new classifier which will take build classifier function as input and batch size 1 and cv10 and n jobs minus 1. Now cross-validation function with cv10, that is k folds, 10 folds it will take. That is the combination of training and tested of 10 folds for our cross-validation is going to take. N jobs here is minus 1, that means CPU number of CPUs used here will be minus 1, that's all the CPUs. So it's gonna, now we have run it, and after running it took really like 3 to 4 hours of time we have run it on this. You can see on this it took so much of time after running 3 to 4. Oh, and it's going to take a while. ANN will train 10 trained k-folds, and each time it's going to measure accuracy. So 10 accuracies we have here. In our accuracies we have taken output as arrays 85, 84, 88, 84 and 85 like that. Here accuracies we have taken mean, it come 80.85.5, and standard deviation as low variation we have got, that means good accuracy, that's good model.